Medicinal chemistry is the science that deals with the discovery and design of new therapeutic chemicals and biochemicals and their development into useful drugs. In this video, I'll be sharing insights on how organic chemistry is indeed playing a very crucial role in drug discovery. Now, a drug is a molecule that is used as a medicine or components in medicines that are used to diagnose, cure, mitigate, treat, or prevent diseases. Now, medicinal chemistry as an aspect of organic chemistry may involve isolation of compounds from nature or synthesis of new compounds, investigations of the relationship between the structure of natural and synthetic compounds and their biological activities, elucidation of their interactions with receptors in the body, receptors of various kinds, including enzymes and DNA, determination of their absorption, transport, and distribution properties, studies on their metabolic transformation, their excretion, and toxicity. In the world today, harnessing modern tools to construct rational drug design is pursued intensely in the laboratories of pharmaceutical and biotech industries, as well as academic and research institutions. Chemistry, especially organic chemistry, is at the center of these endeavors. Now, from the application of physical principles to influence where a drug will go in the body and how long it will remain there, to the understanding of what the body does to the drug, to the synthetic organic processes that are used to prepare a compound for testing, first in small quantities and ultimately if successful on a multi-kilogram scale. Now, at this point, it is important for us to note that drugs are not generally discovered. Yes, you heard me say that. What is more likely discovered are called lead compounds. Now, the lead is a prototype compound with a number of attractive characteristics, including the desired biological and pharmacological activity, and may have other unwanted properties like high toxicity, other biological activities, absorption difficulties, insolubility, distribution problem, and so many others. Now, the job of the organic chemist is to modify the structure of the lead compound in order to amplify the desired activities and to minimize or even eliminate the unwanted properties to a point where we have a drug candidate. Now, it is important for us to note that when you use a drug, depending on the nature of the drug and also the mode of administration, the drug will travel throughout the body, essentially places that the blood vessels can get to. Now, it is not as though when you use a drug, it travels directly straight to the site of action. No, it goes to other parts of the body, and that is why we have side effects. When the drug goes to somewhere or interacts with a receptor or a substrate that is not even required to bring about any therapeutic effect. I hope I said that right. Now, in this video, I want to share insights on how organic chemistry is indeed playing a very, very important role in drug discovery. Now, let us take a look at the coronary heart disease, which is simply the buildup of cholesterol-containing plaques on the walls of the arteries. Now, because the internal surface of the arteries is coated with cholesterol, there is restriction in blood flow and eventually leads to heart attack. Now, heart-related diseases is the number one killer in the world today, even ahead of cancer. Now, the onset of coronary heart disease is directly correlated with the blood cholesterol levels. And the first step in preventing this disease means we need to lower our blood cholesterol levels. Now, the funny thing is that it appears that only about 25% of our blood cholesterol is actually gotten from what we eat. We've always had this campaign on making sure that we cut down the intake of cholesterol. Yes, it is very important, but research shows that only 25% of our blood cholesterol is gotten from what we eat. Now, you may want to ask, where does the 75% come from? Now, the 75% comes from our body, biosynthesis in our own body. Now, the first step in preventing this disease means lowering that level. That is, lowering the amount our body biosynthesizes. And that means an understanding of the chemical processes that make up the cholesterol biosynthesis. Now, this reaction occurs several times in our body every day. Now, there is the conversion of a compound known as 3-hydroxyl-3-methyl glutaryl coenzyme A, which is popularly known as HMG-CoA, to mevalonate. Now, as we can see, this compound has hydroxyl group at the position 3 and also a methyl group at position 3, and that is why it is essentially called 3-hydroxyl-3-methyl coenzyme A. Now, the conversion of this compound into mevalonate is catalyzed by an enzyme which is known as HMG reductase. Now, the strategy that is employed in the treatment of this disease is to make sure that if we can prevent the conversion of 3-HMG-CoA into mevalonate, we are in a way modulating, or if you will, reducing. But because essentially our intention is not to stop the biosynthesis of cholesterol totally, we are trying to modulate that effect, because in this disease there is hyperactivity in the sense of the production of cholesterol, which is then leading to the accumulation in the arteries. Now, if we are able to design drugs that can stop the activity of the reductase, then we are in the right direction in treating this disease. It looks fairly very simple, it looks fairly very easy, but it requires, number one, understanding the chemical reactions that make up the biosynthesis of cholesterol. Also, we need to understand the structure of the reductase, the enzyme, identify the active sites in the enzyme, and also look at how we can design drugs that can inhibit the activity of that enzyme. And that is the job of the common drugs that are used, which are statins. We have simvastatin, rosuvastatins, and so many other members of that class of drugs are called statins. And what they do is they inhibit the activity of the reductase. Therefore, HMG-CoA is not converted to mevalonate. So that is just an example out of many examples of how organic chemistry is in fact the foundation of drug discovery. Till I see you next time, stay safe and have a good weekend.